Hello again, welcome to another lesson in geometry. Today we're covering section 6-4, properties of rhombuses, rectangles, and squares. Alright, so vocabulary. Circle the segments that are diagonals. So remember the diagonal goes from one corner of a polygon across the middle to its opposite corner. So we're going to have AE and CG or GC, whichever one's in here, so GC. Okay. None of those others are diagonals. Going from a side across is not the same as going from a vertice of our polygon across. Okay? So if a diagonal ever a line or array, and this is no, they're always going to be line segments because they have endpoints on both sides. Okay? The diagonals of a quadrilateral JKLM are what? Okay, well let's take a look. Let's draw one. Here's a quadrilateral JKLM. Remember, you need to name it in the order that they come. And then our diagonals are going to be JL and KM. Now you can read that from here by getting the angles that are not consecutive. So JL and KM. All right, vocabulary builder. A rhombus. So a rhombus is a parallelogram with four congruent sides. So we know it's a parallelogram, so it has opposite sides parallel, but it also has four congruent sides. You can kind of think of it as a square that's been knocked over in the wind, okay? Just like a parallelogram is like a rectangle that's been knocked over in the wind. So a rhombus has four congruent sides, but not necessarily four right angles. So a rhombus could have four right angles. And there's some examples here, a diamond and a square. Those are both rhombuses, okay? So complete each statement with always, sometimes, or never. So a rhombus is always, sometimes, or never a parallelogram. Well, this is always, because that was in our definition. It's a parallelogram with four congruent sides. Okay? A parallelogram is always, sometimes, or never a rhombus. This is going to be sometimes. Parallelograms that have four congruent sides are rhombuses, and parallelograms that do not have four congruent sides are not rhombuses. Okay? So a rectangle is a rhombus. This is once again going to be sometimes. Why is it sometimes though? You say, well, a rectangle, they don't have congruent sides, all four. But remember, a square is a rectangle. So here is a rectangle that is a rhombus. It's also a square. Okay. So a square is a rhombus. This is always. Every square is going to be a rhombus. A rhombus is a square. Once again, this is sometimes. If it happens to have right angles, it is. If it doesn't, it's not. Okay. So a rhombus is a hexagon. This is our one chance to write never. A rhombus is a quadrilateral because it's a four-sided figure, because a rhombus is a parallelogram, which is also a quadrilateral. Okay. All right, let's flip it over and see what's on page 2. Okay, at the top of the second page, we have a key concept, special parallelograms. So we have three special parallelograms. We have a rhombus, a rectangle, and a square. So we've talked about a rhombus a little bit. A rhombus is a parallelogram that has four congruent sides. Okay. A rectangle is a parallelogram that has four right angles. Notice it doesn't say anything about the sides being congruent, so there's no requirement for congruent sides. And a square is a parallelogram that has both of those things. So it has to have four congruent sides and it has to have four right angles. So a square is a rhombus and a square is a rectangle, okay, but not necessarily the opposite way. Okay, so let's do a diagram here. So rhombuses I'm going to have to put over here in this circle or rectangle, but we're going to go with rhombus over here. Now, remember we said a square is a rhombus, so the squares are also all inside the rhombus circle because every square is a rhombus. So I got to put the squares in here. So this is the little circle for the square, okay? And notice that blue circle is inside the rhombuses, okay? Because every square is a rhombus, but the rhombus has extra stuff because there are some rhombuses out here that aren't squares, okay? All right, now the other way, we can put rectangle over here. All right, so the rectangle circle goes like this. And notice the blue circle is also inside of the rectangle circle. And that's because every square is a rectangle, But there are some rectangles out here that aren't squares. Now, the ones that are in the middle in this blue circle are squares. But a square is also a rhombus and a rectangle, and that's why the blue circle is inside of both the green and the red one, because the blue circle contains squares, which are extra special. They have all the properties of rhombuses and rectangles. Okay, so a square could be a rhombus or a rectangle, but not the opposite way around. A rhombus is not necessarily a square, and a rectangle is not necessarily a square. Okay. Now, there are some rectangles that are rhombuses. Those are called squares. And there are some rhombuses that are rectangles. Those are called squares. That's why the squares are in both circles. All right, problem number 1, classify special parallelograms. If parallelogram EFGH is a rhombus, a rectangle, or a square, which one is it? Explain. So circle the number of sides marked congruent in the diagram. Well, we have 4 congruent sides marked. Do we have anything about angles? No. Anything about right angles? Definitely no. Okay. So is it a rhombus, a rectangle, or a square? So this is a rhombus. It has only 4 congruent sides. Now you might say, well, it might not even be a rhombus because it could not be a parallelogram. But remember, it is a parallelogram because its opposite sides are congruent. That's one way to prove a shape is a parallelogram. So this shape is definitely a parallelogram, and it's a special parallelogram. It's a rhombus because it has 4 congruent sides. So it is a rhombus. It has 4 congruent sides. Okay. It doesn't say anything about angles, so we don't know anything else. All right. Theorem 613 and 614. Theorem 613 is a parallelogram. Is a parallelogram a rhombus? Then its diagonals are perpendicular. And theorem 6-14, if a parallelogram is a rhombus, then its diagonal bisects a pair of opposite angles. All right, so if we have a rhombus, let's look at this picture up here again. Then the 6-13 says the diagonals are perpendicular. So if I connect this diagonal and this diagonal, I should get right angles in here. Now remember, a parallelogram already said they bisect each other, so these diagonals bisect and are perpendicular bisectors for each other. Okay. All right, our second thing says if it's a rhombus, then the diagonal bisects a pair of opposite angles. Sorry. So our opposite angles are E and G, maybe, and it bisects both of those angles. So these two get split perfectly, and these two get split perfectly, and actually all 4 of them are the same. Okay, so if ABCD is a rhombus, then AC is going to be perpendicular to BD because its diagonals are going to be perpendicular. If ABCD is a rhombus, then AC is going to bisect angle A, and well, we should name it with a big thing, angle BAD, because we have extra lines in there. And it's also going to bisect angle DCB, or BCD. Okay. If ABCD is a rhombus, then angles 1, 2, 5, and 6 should all be congruent. If ABCD is a rhombus, then BD, this guy, should bisect angles what? Let's see, BD is going to bisect angle ADC and angle ABC. And that's going to make angles 3, 4, 6, and 7 all the same. All right, let's flip it over and learn some more about these special parallelograms. Okay, on our third page, we have problem number 2, finding angle measures. What are the measures of the numbered angles in rhombus PQRS? So the numbered angles are 1, 2, 3, 4, and we want to find their angles. So circle the word that describes a triangle PQR and triangle RSP. So this is a rhombus. That means all the sides are congruent. So if you look at those 2 triangles in there, then we know we have each one of them has 2 sides the same. So they have isosceles triangles. Circle the congruent angles in triangle PQR. So the congruent angles are going to be opposite of the congruent sides. So angle 1 and angle 3 need to be circled. And then underline the congruent angles in triangle RSP. So in triangle RSP, PS and RS are the congruent sides, so opposite are going to be angle 2 and angle 4. So we'll underline angle 2 and angle 4. Okay. All right, we don't do anything with Q and S. So the measure of angle 1 plus the measure of angle 2 plus 104 should be 180. And that's because this is a parallelogram, so consecutive angles should be supplements of each other. So 1 and 2 and 104 are going to make 180 total because 1 and 2 are supplementary with the 104. All right, so the measure of angle 1 plus the measure of angle 2 is now going to be, let's see, we subtract 104 from both sides. So that should give us 76. And then that means that the measure of angle 1 is going to be, well, 1 and 2 are congruent to each other. So 1 is going to be half of 76. And half of 76 is, let's try this with a calculator here, 38. So it's going to be 38. Okay. Each diagonal of a rhombus, let's see, is going to, each diagonal is going to bisect a pair of opposite angles. So it's going to split the opposite angles in half, and that's why 1 and 2 are the same and 3 and 4 are the same. So circle the angles in rhombus PQRS that are congruent. So 1, 2, 3, and 4 should all be congruent to each other. And that means since the measure of angle 1 is 38, then the measure of angle 2 should be 38, and 3 should be 38, and 4 should be 38. So these should all be 38. All right. We have one more theorem here on this page. It's about rectangles. It says if a parallelogram is a rectangle, so we have a parallelogram, and that parallelogram is going to be a rectangle, so we have right angles, then the diagonals are actually going to be congruent to each other. So this diagonal in blue is going to be congruent to this diagonal in red. So they're going to be the same length. So if RSTU is a rectangle, then which should be congruent to each other? So the diagonals should be congruent, so RT should be congruent to SU or US, whatever way you want to name it. Okay. Problem number 3, finding diagonal length. So in this rectangle here, okay, we have the length of both diagonals. One diagonal in red is going to be 4x minus 17. And the other diagonal in blue here is going to be 2x plus 13. Okay, and we need to find the lengths of the rectangle. So underline the correct word to complete each sentence. LMNO is a rectangle. The diagonals of rectangles are going to be congruent. That's what the theorem above said. Complete the sentence. LN should then be congruent to MO. Okay, and that means that 4x minus 17 should equal 2x plus 13. So we'll take that equation and use that to solve for x. So I'll subtract 2x to both sides. So 2x minus 17 is equal to 13. And then I'll add 17 to both sides to get 30. And then divide by 2, and I got 15. Now use the value of x to find the length of LN. So the length of LN, I just have to plug x back into it. LN's formula was 4x minus 17. So in place of x, I'm going to put 15. So 60 minus 17 makes 43. So the diagonals of the rectangle are congruent, so the length of each diagonal is 43. They have to be the same length. Okay. All right, let's flip it over. On our last page, we have a lesson check. And as always with lesson checks, pause the video, try it yourself, and then come back to see if you actually learned. Welcome back. For our lesson check, we have another error analysis. Your class needs to find the value of x for which quadrilateral DEFG is a rectangle. So we want to get the right x to make it a rectangle. The class makes work is shown here. What is the error? Okay, so they took the two values that they knew and set them equal to each other. much like we did on the last page, except the last page we were talking about the diagonals of a rectangle, which are congruent. We did not talk about the angle that's been bisected by the diagonal or been cut by the diagonal. Okay. All right, so write true or false for each statement. So if a parallelogram is a rectangle, then each diagonal bisects a pair of opposite angles. This is false. The diagonal cuts across it, but it doesn't split it into two equal parts. That only works for rhombuses, which means it also works for squares. Okay? So if a parallelogram is a rhombus, then the diagonal bisects a pair of opposite angles. That's true. Okay? So this is why we can't use what their classmate used. We have to think of another way. So if DEFG is a rectangle, then all of the angles should be equal. So E, F, and G. And on top of that, all the angles should be 90. That's what makes it a rectangle. It has 90 degrees in all the corners. Okay, so a parallelogram with all angles 90 degrees. So what's the error in theirs? They thought that let's see, so they used the fact that, maybe I'll write that up for now. They confused the fact that diagonals were the same. That in a rectangle, diagonals are congruent. With a rhombus where diagonals bisect an angle. Okay. All right, so find the value of x in this rectangle. Well, what we're going to have to do then is use the fact that these two angles together have to form a right angle. So 9x minus 6 and 2x plus 8 should be complementary. So we can use that to solve for x. So 9x minus 6 plus 2x plus, what was that, 8 should be 90. All right, and then we can solve for x in this one. So we're going to get 11x plus 2 equals 90. So 11x is 88, and x is going to be 8 to make this work out. So the value of x in this rectangle should have been 8. All right, so check off the vocabulary words that you understand. Hopefully you know what a parallelogram is, a rhombus, a rectangle, a square, and the diagonal of all of those, which you've been working out for a while. And how well can you find angles and diagonals of special parallelograms? So if you're having trouble remembering what the diagonals do on a rhombus or a rectangle or a square, then you want to go back and watch the video again. All right, see you in class next time.